I like what we're doing today.
Cool. Yeah, so we are definitely going to basically throughout the lesson today have a lot of fun. Okay, let's get going. So what I want to do is I want to start with a little review of strategies for solving equations. So today's lesson is going to be all about solving equations. So what we have here is we have a first equation, and I want you guys to tell me, what do you think the first step is going to be for that? And I want you to pop it in the chat. So what is the first step that we need to do? And then while you do that, I'm just going to open my windows. So it's a bit... Okay.
Ooh, Melusi is right there to answer our question.
Okay, so what is the first step? Oh, sorry, Melusi, I'll unmute you. Go ahead.
Hi, sir. Can you hear me?
Loud and clear. Go for it. What's the first step?
Sir, so like basically whatever's outside of the brackets, you times it with what's inside. So you'd say 2 times 4 and
Okay.
4 times 1.
And what do you get for your 2 when you multiply out?
It would be 8x.
Okay, and then?
Minus 4.
Perfect. And the other side, can you help me with that one?
You do the exact same thing. So you say 5 times x. So x is basically a 1. So it'd be 5x minus 10.
Fantastic. Thank you so much, Melusi. I'm going to... Fantastic.
Thank you, Melusi. Well done.
In today's equations, you're going to find a lot of the time you're going to have to multiply out the brackets. But then we get left with the situation at the top that I've described, where we have variables on both sides. And so I'd love for someone to come online and tell me what strategy, what process do we use to normally deal with variables on both sides. So someone else, if you put your hand up or put your answer in the chat, that would be awesome. Because
Come
you're
on,
going to
guys.
see it again and again today. So I'm going to go to Mac. And Mac, if I could...
Melusi is on fire.
Sir, can you hear me?
Loud and clear, Mac. What do you think we have to do?
I think we have to group with the like terms.
Perfect. So you saying, if I'm rephrasing what you're saying, get all the like terms on one side and then get, basically get them, if the terms have variables, put them on one side. If the terms have constants, put them on the other side.
Yes.
Okay, now, what rule of equations are you going to use to do that? How are you going to do that?
Well, I'm going to move the 4 and the 5 on different sides.
Okay, let's start with the 4. Describe exactly what you're doing with the 4 in order to get it to the other side.
I plus it.
Yes, exactly. So you add 4 to both sides and you end up with, so I'm being sneaky and I'm not even writing the plus 4 on the left-hand side, but I know that in my mind, I'm adding 4 to both sides. Okay, but now I'm stuck with this 5x over here. What do I need to do for that?
So
if you, I'll give you a hint. If you've got plus 5x on the one side, what's the opposite of plus 5x?
minus 5x.
Okay, so what I'm going to do is I'm going to take away 5x from both sides. If I take away 5x on the right-hand side, I get that. If I take away 5x, if I take away on the left-hand side, I get that. If I take away it on the right-hand side, I get that. Are you happy with what I did there, Max?
Yes.
So I know that I was kind of taking the long route, but I was trying to show you that I was always doing the same thing to both sides. Now, finish it off with me. What is, add my like terms together. 8x minus 5x is what?
8x minus 5x is 3x.
Perfect. And then on this side, we've got minus 10 plus 4.
Which should be minus 6.
Okay, we're almost there.
Girl.
We're almost there. In order to solve an equation, we have to isolate the variable. We have to get the x lonely by itself. The problem is The 3 is still there. Can you tell me what you would do to get the x by itself?
I divide both sides
By what?
by 3.
Perfect. And so your final answer will be?
X equal to
2 or what? Remember, there's a -6 over here, and -6 divided by 3?
would be -2.
Okay,
Well
perfect.
done. Well done, girl. Well done.
So everyone, what I want to make sure is we are warming up for today now. So I'm showing you an example of a question, a strategy that we're going to use today. But there may be places where I'm losing some of you. So if there are questions, put it in the chat, because we're going to practice this method again and again. But all you're going to see me doing is the following. You're going to see me basically either multiplying out brackets, collecting like terms. So collecting like terms is like when we put the x's together, the numbers. And sometimes we have to move things from one side to the other. Whenever we move things from one side to the other, you always see me say you're doing the same thing to both sides, because that's the only way you can solve an equation, is by always doing the same thing. If you don't do the same thing on both sides, you break the equation and you won't get the right answer. So you'll start to almost get sick of me saying this, but I promise you in the long run, it's for your benefit. Okay, let's try. I want you guys to try and do question 6.1.3 using the same strategies as what we did now. So I want you to try and solve that for me, and then I'll go through it with you. So don't we need plus and not minus? So Tando, do you want to raise your hand and have a further conversation while students are working on this question? I'd love to know what you mean. And while students are working on that.
Sir,
Hi, Tando.
on the previous question, on 8x minus 5x equals, so don't we need to add instead of minus, because on top it says -4, but on the other hand you said minus 5x.
Okay, if you look at what I did, are you happy that we have a 5x on this side?
Yes.
Are you with me on that side? Now, what I did was I said, look, I really want to move this 5x to the other side. And the way I'm going to do it is I'm going to take away 5x first on the right, what's it going to be, on your right-hand side. Now, if I take away 5x on this side, I'm basically just crossing out the 5x that's already there. But then, in order to balance the force, I have to also take away 5x on the other side. So I'm doing it in one step. So all I'm doing really is I'm taking away 5x from both sides. Now, once I do that, I realize 8x minus 5x is just going to give me the 3x below. Does that help?
So don't you need to add, because it's 8x minus 4, but here you minused.
Okay, what I'm doing is I'm not actually, okay, I know what you mean. The -4, I'm actually moving that to the other side. So Tando, if you think about this, if I add 4 on this side and I add 4 on this side, what you'll notice is it knocks out the -4 and the +4 here. And then I just end up with a +4 on that side. So I don't actually let the 8x and the -4 interact at all.
Okay.
Yeah. So I'll show it to you again now when we do the next question. But this idea of adding or subtracting the same thing based on the question. So let's actually see this next one. Let's do it together, Tando. Tell me your first step for 6.1.3.
It's 2x minus 8, of course.
Okay. And we have, basically that's what it simplifies to. Now, there's a couple of steps you could do, but I think what might be a good idea is to collect these two like terms together. And could you add these two together for me?
Okay. 8 plus 4. -4, sir.
All right, so we can replace those two yellow numbers with just the number -4. Now, some students may have chosen to move them across already, but both methods will work. I call this collecting like terms. Okay, now
Sir,
yeah,
I think I'm getting what you're doing. And you are trying to make the sum shorter by adding or minusing the like terms, if I'm correct.
exactly.
Oh,
That's exactly what I'm doing, Tando. Exactly.
okay. Thank you, sir.
Pleasure. So from here, guys, I'd love someone to tell me in the chat or raise your hand, what's my next step going to be? And remember, I'm following the same process. I'm trying to make the x lonely, but in order to do that, I need to, yes, 7IT. I add 4 to both sides. And as I get more comfortable, I realize if I add 4 to the left-hand side, sorry for the siren, I just get 2x. If I add 4 to the right-hand side, I just get that. Now, that's a bit more difficult than the first lesson I did with you. In the first lesson, I was showing you, I'm going to add 4 here, and I'm going to add 4 here. But after a while, you start to notice this pattern that I'm always knocking out one of the things deliberately. I'm getting rid of it on purpose. So I know it's going to go away. I just have to make sure I balance it by adding to the other side. So now we've got 2x is 12. And then my last step, pop it in the chat. What do I need to do to get x to be lonely? So x is going to be 6, Rachel, I agree. All I'm going to do is I'm going to divide both sides by 2. And again, just to point out why I'm dividing by 2, at the moment, the 2 is being multiplied by x. What's the opposite process of being multiplied by 2? It's divided by 2. And am I doing it just to one side? No, I'm doing it to both sides. Why am I doing that? Because things that are equal stay equal if you keep doing the same thing. And so my final answer will be x is 6. Okay, we will make you ninja equation solvers yet. So it's
Definitely.
time. So if there are any questions or if anybody wants to take a screenshot, now is the time. And then we're going to move to some more examples. But take your screenshot if you need to.
Shine, people, shine. Let's take screenshots and remember to mark your work. So it's good to mark and be like, oh, did I get my 4 marks or my 3 marks?
Okay.
You know, it will be good for you.
Let's take it up a notch. So good people, I'm going to give you one sneaky little bit of help for this question. In this question, the left-hand side is pretty much what you've seen before. The right-hand side, I'm going to give you one little tip. There's actually a phantom -1 hiding in here. So whenever you see a minus and there's no number there, there's actually a 1 there. But I want to see, can you solve this or get close to solving it by yourself? And if you get stuck, what I would love is I'd love you to raise your hand and have a chat with me. But the rest of us, if you feel like you're sort of comfortable with this, I want you to give it a go. If you're stuck, pop a question in the chat or raise your hand. Okay, off we go. Let's do this.
Let's do this, guys. Teacher Peter is so nice to us. I thought that will trap some of us, you know, that invisible one over there. Because I know that if I solve this kind of stuff, I forget that there's an invisible one there. So
one of my maths teachers used to call it the phantom one because it hides there. You know, like it's there, you can feel it, but you can't see it.
The phantom one.
Yeah.
It's a good one.
Yeah. So, cool.
Let's do this, guys. Oh, I see everybody focusing. Oh, wow. Jamie Frank, I want to see your answer. Let's go. Let's go.
Yeah. And there are, I mean, while you're doing this, there's not one correct way to do this. So there's a couple of different routes you could take, but what you have to do is always apply those two rules. Whenever you always use opposite operations, and you always do the same thing to both sides. That is, all correct methods will have that. And a lot of you will also have to distribute brackets. So you're going to have to practice the skill of distributing brackets. Jamie I'm not quite sure what it, I need to learn emoji language. I'm a little bit old for that.
I think Jamie is just saying that because Mem said my name, I want to talk. But Jamie, I'm muted everybody. So you got to raise your hand and then we can unmute you if you are coming here to either give us an answer or you have a question. You're welcome to raise your hand and then I can unmute you.
Yeah. So if you raise your hand, we'll unmute you.
Luyanda, go. So did you already solve it? That was some fire over there. I don't know what the answer is, but Luyanda has an answer.
So we'll find out in a bit of time what's going on if we agree. But for the moment, I just want to give you the first round, and the first round of multiplying out. And I think I might catch a couple of people with this bit. So have a quick look and see if you understand what I've done. And if you don't, please pop your hand up or pop a question in the chat, because that minus phantom 1 is quite, it affects both of these things over here. Yeah. Malusi. Let's unmute you. Hi, Malusi.
Sir.
Yeah.
You see, like by the like outside the bracket where you put like the red one.
Yeah.
When you have like these type of sums, excuse me.
Yeah.
Are you gonna put like imaginary ones like there all the time?
Yeah. So normally, Malusi, what you would normally have in the question is you'd normally have like minus 2x minus 3 there, and then most students will understand that it's minus 2 times x minus 2 times minus 3. What tends to catch students out is when they see like a negative hanging out by itself, it kind of almost feels like, is it a multiplication? Is it a subtraction? And so what I say to students is if they see a minus outside a bracket, just put a 1 there, because it helps our brains understand that really this thing outside is being multiplied by what's inside.
Yes.
Does that help, Malusi? So it's most
Yes,
of the time there's a number in front. Yeah.
So if there's like a negative 2 and then there's a bracket like 4x minus 5, would you
Yeah.
say negative 2 times 4x
Yeah.
times 5?
The moment there's
And
a
then-
bracket next to a number, it implies multiplication. Yeah.
Oh, okay. Thank you, sir.
Cool. Okay, so my next step, guys, is what I would do in this question is I would collect like terms, and on the left-hand side, the like terms are just the 9 and 9, so I get minus 18, and on the right-hand side, I get my 7 and 5, so I get my 12 minus 4x. Okay, so that's, now we're not done yet, but what we're going to do is we're going to try and do two things. I'm going to try and move the minus 4x to the other side. And I'm also going to try and move my minus 18, let me get yellow, minus 18 to the other side. Now, if you want, you can do it in multiple steps, but I'm going to do it, basically I'm going to write down my 6x because I know it's staying there. And then I want to deal with my minus 4x. I would like someone to tell me in the chat or by raising their hand, how am I going to move the minus 4x to the other side? What is going to give me the power to move it across? I can't just move it across and I don't know how it got there. Okay, Tatenda, let's go to you.
Good morning, sir.
Tatenda? Hello,
Good morning, sir.
What do we do with the minus 4x? Can you help me?
We're gonna turn it to a plus.
Plus. And am I going to add it to one side or am I going to add it to both sides?
We're gonna do it to both sides because what we do at the right, we do to the left.
Okay.
Yes,
So,
Latenda, well done.
so what we're going to do is we're going to add 4x on the right-hand side. And when I add 4x on the right-hand side, the blue bit's going to go away. And then it's going to, I also add 4x on this side, and I get that there. So are you
Yes,
happy
sir.
that it's reappeared on that side? Now, while I've got you, what about this minus 18? What do I do with the minus 18 to move it across?
I think it becomes plus 18.
Okay, so but in terms of this language, what's the opposite of minus 18? It's plus 18. And what am I going to do? I'm going to add 18 to both sides.
Yes, sir.
And when I add the 18 to the left-hand side, it knocks it out. And then I just add the 18 on this side over here.
Oh, I understand now.
You see what every time I'm always doing a movement on both sides, and then I knock out the one side and then reappears on the other.
Other side.
Okay, last step. Let's collect like terms. What's 6x plus 4x?
10x.
Fantastic.
Well done, man.
12 plus 18. I'm putting you on the spot. Sorry, Tatenda. I think we may have lost contact.
He's still
there.
with us. He's
Oh,
still with
okay.
us.
30, sir. 30.
Well done.
Fantastic. Tatenda, you have been hugely helpful. Thank you so much.
Welcome, sir.
And the last step is clearly to divide by 10 on both sides. And so our answer will be x is 3. So guys, I know I'm making it a little bit, I'm doing less steps today, but I'm really coming back. I just want to get a quick feel. How are we feeling? So give a thumbs up if you feel like you're mostly following. Give a thumbs down if you feel still a bit like, I'm still hanging in there. I just want to get a feel for the group. Okay. So all I want you to do now is we're going to do one more example before the break. And I just want you to think about the steps. And if you get stuck, what we'll do is we will just keep practicing. Okay. So let me quickly do this one. Let's try this one before the break. So I'm going to do that, and then I'm going to zoom in. So guys, this question is, it says solve the equation 3x plus 5 equals 2 times x minus 5 minus 6. And I'm just going to give you some time to have a go at that. And then let's see if it feels a little bit easier than last time. And
Let's do this, guys.
If you need a bit of extra help, then let's have a conversation.
Yanda is on fire. Oh,
also, what I'd like to know from students, if you are feeling a bit confused, I'd love to know at what step I'm losing you.
Yeah.
That could be quite helpful. When I'm doing it, I want you to put in the chat or raise your hand as I'm doing it. Show me where I'm losing you. Maybe I'm doing it a little bit differently to how you do it in class, and that's okay. But we will kind of focus a bit more now on the idea of moving things across from one side to the other. Maybe that will help a little bit more.
So guys, this is your chance, as Teacher Peter has explained. So if you do not understand the first step that Teacher Peter is going to do now, raise your hand and you can do it with Teacher Peter.
Okay. Here we go. Hi, Tandy.
Good afternoon.
How's it going?
Hi. I'm confused with the first step.
Okay. I want to suggest that the first step is to deal with the brackets. Would that make sense to you? To like deal with the bracket first? Could you help me? What do you think the relationship between the 2 and the bracket is?
2x.
Okay, but it's the relationship is to multiply, hi? So you get 2 times x is 2x, but now you must also multiply the 2 by this. And what do you get for that?
$10.
Okay, but you get negative 10, huh? So that would be my first step. So notice how I've just rewritten the left-hand side. Now, if you're Tandi, if you look at the next step, what do you think I'm going to do next? Or what would you do next here?
Group the like terms.
Exactly. And so for me, the like terms at the moment would be these two. And so can you help me by telling me what minus 10 minus 6 is going to be?
Negative 16.
Okay, perfect. Now, we have a new type of problem. You've got through problem number 1. The next problem is that we need to get all the variables on one side and we have to get all the numbers on the other side. And what I said in the previous question is basically we're going to have to deal with the 2x, I think, to move it across somehow. And we're also going to have to deal with this plus 5. We're going to have to move it across. Does that make sense to you that they're kind of getting in the way?
Yes.
Okay. Let me ask you, how would you deal with the 2x? How would you move the 2x across?
You put it across by saying minus 2x.
Exactly. So it becomes 3x minus 2x. And I've left the 5 out for now. But basically, if you take away 2x from both sides, you get the negative 2x on the left-hand side. Now, what about the plus 5? How do I move that across to the other side to join the minus 16?
I'm not sure, sir.
Okay, let me ask you this. What is the opposite of plus 5?
Minus 5.
Okay, so if I take away 5 on this side and I take away 5 on that side, do you agree that this gets knocked out?
Yes, sir.
So then I'm basically left with that some people would say I move the plus 5 to the other side and I get a negative 5.
Sir, don't you put the minus 5 in front of the minus 16?
You could. It will still give you the same answer. You basically take away 16 and you take away 5. So let's do this last. What is 3x minus 2x?
1x.
1x or just x, yeah? What is minus 16 minus 5? So you lose 16 and then you lose 5 more.
Negative 21.
And just like that, you've done it. Okay.
Oh.
So you just
There we go, Tandy.
You just need more practice, Tandy. And if we look at the processes we did, let's have a quick little walk down memory lane. So step 1 was multiplying out the brackets. Step 2 was collecting your like terms, like you told me. And then I had to deal with the green and the yellow bits. And in order to do that, basically what happened was some students would say you move the 2x to the other side and it became minus 2x, although secretly we know we were taking away 2x from both sides. And then you move the 5 across. And really what you were doing is you were taking away 5 from both sides. So does that kind of make a bit more sense than before?
Yes, sir. Thank you.
Pleasure, pleasure.
You did well, Tandy. Well done.
It is time for a stretching break because we have been working so hard. So I want everyone on their feet and I want to see your best stretching pose. Yolanda, as always, please let me know the people who are shining brightly. And since Yolanda is at the gym, let's go the extra mile today, guys. Come on, let's see that best stretch.
Yes, please, guys, give me some, some nice stretch so that I can use for my gym. Let's go. Let's go. Azina, I see you. Ooh, Ruvarashe, go girl. Busiso, I like it. Jamie, yay. Yeah, I like what Jamie's doing, guys. Tande, I can see you. Tande, Tatenda, I see you. Amafe, let's go, girl.
Let's do it. Oh, I feel so much better standing up. My body was made for doing exercise, I think. Okay, while you are stretching it out, here is the brain break activity for today. There's puppies and different types of puppies. So you tell me what one puppy plus another puppy minus a puppy plus that same puppy is. Let's do it. Let me turn my light on now. It's got a bit too dark.
Let's go, guys. I see you saying brown puppy is 7. And then yellow puppy, someone said that a yellow puppy is 3.
Okay, let's just make
Let's
sure.
go,
Yes,
guys.
7 plus 7. Must be that one.
They said yellow puppy is 3.
3 plus 3. Yeah, that's the only way we would get to
13, yeah.
13. So, and now what is brown or orange puppy? Orange puppy maybe ate something not so good. So, what is orange puppy going to be, or brown dog? It's going to be, I agree with you, Kanyesile. It's going to be 6, which means that you have to work out this using your logic. What's our final answer going to be? So 7, because it's plus or minus, the order, yeah, so it's going to be 13 minus 3 is 10 plus 6. I get, drum roll please, 16. So
Ooh, well done, everybody.
Micah, Simonati all agree with me. All right. Fantastic.
This was
guys.
gentle, guys. This was a gentle brain break. A
It was.
gentle one.
I'm going to bring some Maths 24 back soon, and then that will also get our brains really kicked into gear. Okay, everyone, let us now, sorry, that's a little bit too zoomed in. Let me bring this down a notch. I want you to try and solve this equation, and I'm actually going to write it out for you so it's a bit clearer. 3x plus 4 minus x minus 24 equals x plus 3 minus 2x. I want you to try and solve this equation. And I want you to just keep calm and think what strategies, there are many strategies you can use, but what combination do you think would work best? And start to trust yourself and go, look, there are choices here, but what would be the easiest? And so over to you guys as you begin solving this equation.
Let's do this, guys. Let's do it. Remember,
Loyal.
write on your books.
We do have a quiz today. Yes, we do.
Write on your books, guys, so you can mark. It's very important. But you guys did well. Oh, you're doing well. Ayanda with an answer already. You guys are on fire.
Give it a moment there. So I think life would get a lot easier if you collected the like terms on each side first. So I think you don't have to do this, but I think it would probably be, or you could move things around too. But I think I would probably go with just simplifying the left and right hand side first. So what is 3x minus 1x? What is 4 minus 24? And then etc. So that's what I would suggest to start with. Lukiwe, I see your answer. Sivanati, I see your answer. Let's give it a moment. So these two together would give me 2x. And these two together, 4 minus 24 is minus 20. And then x minus 2x. That's a little bit tricky. That is 1 minus 2. It's minus x. And then I've got my plus 3 hanging around. Okay, so now my next step. And I think you guys do like the words moving things to the other side. So basically, what you're going to do is you're going to have to move the minus x. But really what you're doing is you're adding x to both sides. And you also are going to have to move the minus 20. But what you're doing is you're adding 20 to both sides. But the effect of that is you get the 2x. And then if you add x to both sides, you get a plus x on this side. And no x is on this side. And if you add 20 to both sides, the 3 was there already. And then there's no 20 on this side, but there is going to be a plus 20. Now see if you can get to the final answer from that point onwards. Now I caught some of you guys because the minus x caught some of you. Can you all see that? So the answer is not going to be 23. It's going to have a 23 involved, but you still need to get. So let me even go back for a second and explain this. For the yellow to be moved to the other side, I added 20 to both sides. For the turquoise minus x to be moved, I added x to both sides. Yes, Luyanda, yes, I see, yes. Okay, so we have to collect our like terms, 2x and 1x, which gives us 3x, and 3 plus 20 is 23. But now the answer is not 23 because the 3 is spoiling the party. So whenever we solve an equation, we always do the step where we do it to both sides. Oh, that's a big red. 3 over 3 is equivalent to 1. So I get 1x is 23 over 3. Let me quickly go through the steps again, because I did go a little bit quickly there. So step 1 was to collect what I called the like terms. So if we go back to the very beginning, you'll notice that the two yellows, okay, I'll do this. This one and this one give us this. Okay, and then this one over here and this one over here give us that. And then this and this give us that. And then the 3 was already hanging around. Then we have a problem. What we really want to do, and people will use different ways of describing this, but we want to move this minus x to the other side. And what ends up happening really is when it comes across the equal sign, it ends up becoming a plus x. Really, the power of that is just doing the same thing to both sides. And then the same thing here with minus 20, when it moves across, it's going to become a plus 20 on this side. Now, I don't like saying move it across because really what's happening is I've added 20 to both sides, but it still works. Then I have to collect the 3 and the 20 to give me 23, the 2x and the 1x to give me 3x. And then the last step is I divide both sides by 3 because of the 3 in front of the x. So, and if you put it into your calculator, you would get 7 2/3. Guys, the question has been asked, which one of these is more correct? These are both correct. There's not one that's more correct than the other. Okay. Let us do one more question for today, but I want to give you a moment to just take a screenshot for this one. So take a screenshot if you need to. and then we'll do one more question today. All right. It's a pleasure, Goleme. I'm sorry, my pronunciation isn't that good, but I gave it a good try. So
yeah, that was a good one.
at least it was comical. At least it was worth a lot. It's like okay, anyway. What I want to do is I would love you guys to do 10.13 for me. So I just want to finish today with 10.13, and those who are really feeling on fire, you can do 10.14.
Let's do this, guys. These are the most ones that I'm like, whoa, look at this. These are quite interesting. Let's do it. Let's do this, my people. I believe in all of you.
So the goal in this is to solve the equation. And all I'm going to say is use inverse processes and do the same thing to both sides. 10.13 is the minimum, but if you're feeling on fire today, then give 10.14 a go as well.
I see my people are really working hard. Well done, guys. You're working. I see that.
My tip is to start with this 2. If only you had a way of undoing this 2.
Luyanda, you had to say which answer for that question.
Yeah.
I'm not sure whether you're answering, yeah.
Oh, Ayanda's answering the previous question, I think. That's the answer for the previous question.
Oh.
Yeah.
10.13.
So for 10.13, I think we need to undo the divided by 2 part. And if I want to undo dividing by 2, in the chat, what undoes dividing by 2? I think it would be multiplying by 2. And so I'm going to multiply this side by 2, and I'm going to multiply that side by 2. Now think about it, the only job of this timesing by 2 is to knock out this 2 here. Because remember, I've designed this, it's not a random coincidence. I'm designing what I do, but once I do it to the one side, I must do it to the other. So I'm left with just x minus 4 equals 7 times 2. But you need to solve it from that step forward. Now, I think that's true. If only I had a way of dealing with the minus 4. So, aha, yes, Ayanda, yes. So I think to myself, what's the opposite of minus 4? It's plus 4. And if I add plus 4 to this side, I get left with a lonely x. But then I must remember I have to add 4 on this side as well. And so the final answer will be 18.
Well done, guys. Well done.
Okay, so
that was impressive.
A little bit sneaky. I want us to try and do 10.14, but I'm going to give you the tip. You have to deal with the plus 12 first. So for 10.14, deal with the plus 12, and then ask yourself, after you've dealt with the plus 12, what other steps do I need to do? But well done, Lakiwe, you're right, it's 18. We're really getting into the heart of equations now, this idea that no matter what they throw at you, you simply have to use the opposite process to get the variable by itself.
Yes.
And you will solve the problem. And that's why I was going on and on about this opposite thing. It's almost like I'm a stuck record, but I just know that if you get that, it's gonna help you.
Yeah, and I just want to say to our newbies, we love you, and we have some recordings of this on the website. You are more than welcome to rewatch it, and also to some of you who are still a little bit struggling, remember, practice makes it perfect. So you definitely should go back and learn this again.
So what I'm going to say with this last question is the plus 12, the opposite of plus 12 is minus 12. If I take away 12 from both sides, I'm going to get this line below. And I suppose this could even be written as 24, really, but now I've got a new problem because I've got this 2 at the bottom, which is interfering with things. Now, how do we undo dividing by 2? What do we need to do? And do we do it to the one side? Do we do it to both sides? And then think along those lines. And when you've got your answer, you can pop it in the chat. Both sides, Leander, always with equations, both sides. Sometimes it's hiding. You can't even, because you knocked something out, you can't see that you did it to both sides, but it's always to both sides. So sometimes I actually will show you, like in this question, I'm going to say to you, I'm going to times this side by 2, and I'm going to times this side by 2 to show you I'm getting rid of this divided by 2. But then I'm still left with a 3x on top. And then on the other side, I'm left with 48. Okay, so now the good news is the x is getting lonelier and lonelier, right? So all that's left next to the x is the 3, but I have to deal with that 3. And so what do I need to do with that 3? Oh, sorry. Divide, absolutely. And not just divide by anything, divide by 3 on both sides. Then we get x. And then what is my final answer? I see a couple of people have put the answer in the chat. My final answer should be 16. Okay, now, everyone, I'm going to ask you to put the link to the quiz in the chat now. There's no doubt that more practices with this will make it easier, but I think we've done a good job of just showing you the principles of how you solve equations and how we combine things like terms, distributing brackets, all these things almost gobbled up inside equations. And so I think if you get stuck with how to set up your equations, always come back to these videos just to get you moving. And to be honest, like anything, the more you do it, the easier it will get. But yeah, thank you for today. And I hope that, yeah, you enjoy the quiz. Cool. Anything from you, Linda, before we...
Thank you, Teacher Peter. I have sent the link to everybody. So everyone, thank you so much for participating. And I think I enjoyed today's lesson. So
cool. So what
Leander, all the best.
Pleasure, man. Pleasure. Oh, there's a question. Okay, I've got a moment. A future. Yeah. Future, I'll unmute you. Do you want to go ahead?
So you said it was a mistake.
How's it going? Oh, guys, there's a mistake.
Future said it was a...
Wait, no, there's no mistake. Wait, 36 minus 12.
I think Future's...
Huh? What did you say, Future?
No, I think Future said that it's a mistake by him raising the hand.
Oh, okay.
Yeah.
I thought you said there was a mistake in the working, but I don't see one. So, all right. I'm going to pop across to our grade 11s, and then I will see you there now. Cheers, everyone. I hope you have a wonderful
Bye, everyone.
And I'll
Thank you,
see you
Teacher
soon.
Peter.